Linear functions. Okay. A review of our graphs. We title our graphs and we call our Cartesian plane is split up by our axes. We have our x-axis and our y-axis. Right where they cross is the origin. And then we split it into 4 quadrants. And those 4 quadrants start in the top right-hand corner, go in a counterclockwise direction. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. And if you pick any point in quadrant 1, let's say I pick this one at random, that point has an x-coordinate of 3, a y-coordinate of 2. Everything in quadrant 1 has positive x values and positive y values. Any point you pick in quadrant 2, so if I pick this point at random, has a negative x value but a positive y value. Any point in quadrant 3 has both the x-coordinate and the y-coordinate negative, and any point in quadrant 4 has a y-coordinate that will be negative. So we can plot points. We always plot our x-coordinate first, followed by our y-coordinate. So can you graph those points quickly? I'll give you a 20-second head start. How did you do? Are your points in this right spot, or did I make a mistake? Which one did I make a mistake on? D is -6, +7, and I wrote -6, -7. So it's got to be up here. And look at that. Perfect. -6, +7. Is this a function? Maybe. Love that answer. Yeah. Almost, kind of, yeah. Yeah. Yes, it is a function. Because we have no x values. If you do the vertical line test, we don't hit any points twice. So the next thing we look at is the distance between points. If we have the point 2, 2, so if I label that point A at 2, 2, and point B, oh, that's point B. My goodness. So we have point B at 2, 2, but point A is at 2, 6. How far away are those points? What's the distance between them? 4. 1, 2, 3, 4. Yes, they are 4 apart. And if you were looking at AB here, how far apart are these ones? Is everybody okay with counting 8? So life is nice and simple when things are straight lines and you can just count the spaces in between them. However, and I apologize, my graphs, one of them got scared of the side of the page and jumped on top of the other one. So you'll just have to draw a grid for your second one. I know. You can just draw the axes. You don't have to draw all the lines in there. But for the first one, we want to find the distance between negative 3, 5 and 2, negative 4. So negative 3 comma 5, negative 3 first, and then 5. There's the point negative 3 comma 5. And here's the point 2 comma negative 4. And we want to find the distance between those 2 points. Well, now we can't just count lines anymore. However, you could tell me how far this is, and you could tell me how far this is. Going from 5 all the way down to negative 4 is a distance of 9. Going from negative 3 all the way to positive 2 is a distance of 5. How does this help us figure out the distance from negative 3, 5 to 2, 4? We can use a squared plus b squared equals c squared. So what do we want to find? We want to find the hypotenuse, which is c squared. We know that one side is 5, so 5 squared plus 9 squared equals c squared. 25 plus 81 equals c squared. And so we get 106 equals c squared. Take the square root of 106 and round it to 1 decimal place, we would get 10.3. So I'd like you to try the second one. Again, sketch your own graph, label the points, and draw the triangle and figure out the distance on the second one. Again, I'll give you a 30-second head start. Negative 2, negative 3. 4 comma 7. This is a distance of 6. This is a distance of 10. And rounded to 1 decimal place, 11.7. How did you do? So, in order to find the distance between 2 points, we could always do this. We could draw a graph, draw the points, and make a triangle. However, sometimes in mathematics, we find that always drawing a picture, that takes up a lot of room. Could there be a faster way? Could we make a formula for this using this idea? And so the next part that we're going to look at is how do we get and make a distance formula. So in a formula, what happens is you start with 2 random points. So the 2 random points that I'm going to choose, I'm going to highlight them here. Random point number 1, I'm going to call x1, y1. And random point number 2, x2, y2. So if we did this with regular numbers, what did we do? We drew the triangle, and then we found out how far this was and how far this was. Now, we have to create mathematics for figuring this out when we use variables. So if we look back at one of the pictures we just did, right? I figured out this was 9. How could I use 5 and negative 4 to make 9? Adding them makes 1, right? But if I subtract them, 5 minus a negative 4, that would make 9. And so in our diagram here, we can find the vertical height saying I just have to take this higher one, y2, and subtract this one, y1, and that will give me the height of that triangle. Similarly, if I want to find the horizontal distance, I can just take x2 and minus x1. Then Pythagorean says a squared plus b squared equals c squared. Now, this is where the formula works with not very nice looking things, because my a, x2 minus x1, then I'd have to square that. My b, which is my height, y2 minus y1, and square that, would equal c squared. When we had numbers, we could actually simplify that. But since we're creating a formula, we would just leave it like this. How would you get c by itself? You would square root both sides. So this becomes our distance formula. Except they usually don't write c. What letter do you think they use for the distance? D. Wow. Here we go. Good save. So that is how your formula looks on your formula sheet. You take any points, and x1, y1, x2, y2, and now instead of having to draw the triangle, you can just plug it into the equation. So here we have an example. Okay? When you're using the formula, the recommendation is to write out your formula first. x2 minus x1 squared plus y2 minus y1 squared. Copy it down from your formula sheet. Recommendation is also to copy it down correctly. Don't write it down wrong. Second, once you've written out your formula, you have 2 points. You decide which one's going to be your first point, which one's going to be your second point. And it doesn't matter, but most people pick the first point to be their first point and the second point to be their second point. And then above your point, write, this is my first point, so write x1, y1. This is my second point, so write x2, y2. What that helps you do is when you have to insert those values into the formula, that just makes sure you don't get them mixed up. So now we can go to our formula, square root. When I go to x2, I go, oh, x2 was minus 1. Minus x1 was minus 3. Whenever I plug in negative values into a formula, I put them in brackets, because sometimes you're going to minus a negative, and that's going to have an effect. Squared plus y2 is negative 11 minus y1 is 7 squared. And using the distance formula is just a matter of working with order of operations. Order of operations says, first of all, we have to do whatever's inside brackets. So here I have 2 sets of brackets. In my first bracket, I have negative 1 minus negative 3. That's equal to positive 2. Whew. So where you're going to make mistakes with the distance formula is working with integers. So be careful, do it slowly. Negative 1 minus a negative 3 is negative 1 plus 3, which will be negative 2. Plus negative 11 minus 7, negative 18. So order of operations, do your brackets first. then square. 2 squared is 4 plus, what's negative 18 squared? Careful with this, because if you go to your calculator and you type this incorrectly like I'm about to do, very typical to do this, negative 18. All right, the mistake I was about to make, which most people do, they go negative 18 squared just like that and push enter, and why is that the wrong answer? Didn't put negative in the brackets. Because technically what your calculator does is your calculator squared 18 then multiplied by a negative, which is the correct order of operations. But this isn't what we wanted to do. We wanted to do all of negative 18 squared. And whether you square a positive number or a negative number, you should always get a positive number. So it becomes 4 plus 324, which is the square root of 328. Square root of 328 is 18.1. All the distance formula is doing is a squared plus b squared equals c squared without having to draw the triangle and label the sides. So it's nice that way in that it takes that one step out for you. Some people don't like the distance formula, okay? Because it's not easy to memorize. And so if you don't like it and you would rather just draw a triangle because you've got a squared plus b squared equals c squared memorized, that's fine. You can do that every single time. But sometimes we get values that are really big, so like drawing the triangles would be huge, or it's just awkward. So the formula does serve a purpose and help us that way. Okay, I'd like you to try this one on your own. All right, check. How did you do? $157, yes. And we get 12.5 rounded to 1 decimal place.